In this video, we are continuing the last part of our organic nomenclature worksheet. We're going to take a focus at looking at our ring structures. So all alkane structures we have seen so far have been chains, either straight or branch chains. However, carbons are also able to form ring structures. When carbon forms a ring structure, we're going to refer to it as being a cycloalkane. So that cyclo is indicating a ring. So the cycloalkane contains a ring of carbon atoms. So here we have some examples where we can see we've got our ball and stick models where we can see the carbons are connected in rings, and then we see our line structure. So we've got a cyclopropane, cyclobutane, cyclopentane, cyclohexane. So rather than being straight across, they loop around and they're connected in a ring. Because they're connected in a ring, they're going to have fewer hydrogens than a typical alkane structure. In fact, they should have 2 less hydrogens than an alkane structure. So looking at these structures that we had, so we've got cyclopropane, cyclobutane, cyclopentane, cyclohexane. We're asked here in problem 9, what's the only difference compared to a straight chain alkane with the same number of carbons? So if we look at the cyclopropane, 3 carbons, parent name prop, ending A-N-E. Cyclobutane, 4 carbons. So we have that 4 carbon but prefix, the A-N-E ending. Pentane here, we have 5 carbons, that A-N-E ending. Cyclohexane, 6 carbons. Hexane. So the difference that we're seeing is that beginning. All of these names are beginning with cyclo. So in naming a basic ring structure, the only difference in that versus naming a straight chain structure is that we're adding the word cyclo to the front. So naming cycloalkanes is very similar to naming chains. The parent name is based on the number of carbons in the ring. The word cyclo is added to indicate a ring. If branches are present, the same rules are followed in terms of giving lowest numbers and alphabetical priority. If there's only one branch, its location is understood to be location 1 and the 1 is omitted. If there's more than one branch, then the 1 is included. And so we'll take a look at some examples. We're asked to name the following structures. So just like we did with our chains, we want to go through and we want to number. When we number these, we number starting on our branch. If I only have one branch, that is carbon 1. Here, because there's only one branch, it doesn't matter what direction we number. The key is to figure out how many carbons we have. So I have 4 carbons. So 4 carbons would be butane. It's a ring, so we need cyclo. And then we have a branch. That branch is a CH3 group, which is a methyl. And it's on carbon 1. Now, if this were a chain, we would start by putting the number and the branch name. But since it's a ring and there's only one branch, we get to omit that 1. So we're going to simply write methyl and then the ring name, which is going to be cyclobutane. Now, we can only omit the number if there is only one branch. If there's more than one branch, we've got to include that number. So if we look at B, I've got 2 branches. We have to number this, and we have to number on the branch that starts first alphabetically. So my branches are a BR, which will be a bromo, and then I have a single line branch. That single line always represents the CH3, so methyl. So I have a methyl and a bromo. Bromo comes first alphabetically, so its location will be carbon 1. Now we've got a ring, so when we number a ring, we could go clockwise or counterclockwise. We need to number so that our other branches get the smallest possible numbers. So if I were to number clockwise, that gives my methyl group a location of carbon 3. If I had numbered counterclockwise, it would give it location 5. We want the numbering that is the lowest, so we want number 2. So just like with our chains, we're going to list our groups alphabetically. So alphabetically, bromo comes first, and it's on location 1. So we have 1 bromo. Then I have my methyl, which is on location 2. So I have 1 bromo, 2 methyl. It's a 6-carbon chain, so 6 carbon would be hexane. And then it's a ring. So we have cyclo. So this would be 1 bromo, 2 methyl, cyclohexane. Now, very similar to our branches. So when we looked at our structures in our previous video, we took structures and we provided names, and we took a name and provided a structure. We need to be able to do the same thing with our rings. So here we have this name, 1,2,4-trimethyl cyclopentane. Just like we did with chains, we identify our parent. So the parent is pentane, 5 carbons. We've got to recognize that we see cyclo, so it's 5 carbons in a ring. So I'm going to draw that pentagon structure. So I've got 5 carbons in a ring. We need to number our ring. When you're drawing, it doesn't matter where you start. You pick a corner that you like and start numbering. So I'm just going to pick this bottom corner. And I feel like going counterclockwise. So I'm going to do 1, 2, 3, 4, and 5. It doesn't matter the direction. It doesn't matter which corner you start in. Pick one, pick a direction, number them. The key will be making sure you stick the branches on the appropriate locations. So my name says I've got trimethyl, so 3 CH3 groups. 1 is on carbon 1, 1 is on carbon 2, and 1 is on carbon 4. Again, you may have started numbering somewhere else. As long as wherever you put carbon 1, you put that methyl, carbon 2, carbon 4, you will have a correct structure. So in this chapter, we have looked at naming branches, we've looked at naming straight chains, we have looked at naming ring structures. The final thing we have to cover in this chapter is dealing with functional groups. So these are going to be groups of atoms that actually impart different properties to our organic compounds. And based on that, we're going to classify compounds into different families.